Alright, welcome to the first video of our next unit. We're going to split up Learning Target 1 into two parts. We have to write recursive and explicit formulas for sequences, and there's two different types of sequences that we're going to talk about. So this first one is about arithmetic sequences. So first of all, just a general definition of a sequence. A sequence is an ordered list of numbers, so go ahead and write in on your notes. We call each of those terms in a sequence, we separate them with commas, and a lot of times we will indicate each term by a sub number. So a sub 1, a sub 2, a sub 3, that would be the first term, second term, third term, and so on and so forth. And then the general term is a sub n. Okay? So these are all the terms in a sequence. And then the other thing to note is that sometimes there's an a sub 0 before the a sub 1, and we'll use that when we're doing modeling with sequences, where we are going to think of it in terms of time, where there's a 0 time and then 1 hour has passed, 2 hours has passed, or so on and so forth. So sometimes the first term will be a sub 0, but let's only use that when we're talking about time in a real world scenario. Alright, so an arithmetic sequence is, just like any other sequence, an ordered list of numbers. But what makes it specifically an arithmetic sequence is that it's an ordered list of numbers where you add or subtract to get from one term to the next. Okay, so we're adding or subtracting to get from one term to the next. And what that number is called, we usually call that D. That's the common difference. This is the constant amount that's being added or subtracted in an arithmetic sequence. So it's actually the change, okay? It's the change between terms, and it's a constant change between every term, adding the same amount or subtracting the same amount every single time. So the recursive formula, okay, so what recursive means? Recursive means defining each term by the term before it. So in general, a sub n is going to be given by a sub n minus 1, meaning the term right before the term we're trying to find. So if we're trying to find the fourth term, a sub 4, we would be doing a sub 3, okay, because that's the terms directly before it, and then plus d. Okay, that's the recursive formula. So you define, what you're going to have to do is you're going to have to define the first term, and then from there, all the rest of the terms can be found by adding the common difference to the term before it. And then the explicit formula, the way that we can actually find any term without having to know. So let's say we want to find the 100th term in the sequence. We want an explicit formula because we don't want to have to list out 100 terms to find out where we're at. So the explicit formula for any term in a arithmetic sequence is the first term plus the common difference multiplied by n minus 1, meaning we're going to add that common difference to the first term as many times as whatever term we're on minus 1. So if we're on the 50th term, it's been added 49 times. So that's where we're at here. So like let's say, well, we'll get to an example here in a minute. Okay. So we've got these two examples. So a sub 1, a sub 2, so on and so forth. Okay, every term is defined by the one before it. And so what I'm looking for is a common difference. And I can see that pretty easily between each of these terms there's 4 being added. So our common difference is 4. Okay. So recursively we can define our sequence. We have to do two parts. We have to define the first term because we have to have a place to start. And then a sub n. And then a sub n will equal the term before it, whatever the term before it is, and then with 4 added, okay? And then the explicit formula we're going to find by following that format, but I want you to understand where it comes from as well. We take the first term and we are going to add the common difference and we're going to multiply that n minus 1 times. Because let's say we're on the fifth term, so 3, 7, 11, 15, 19, that's the fifth term. So basically we have 3 and we've added 4, 1, 2, 3, 4 times. So if we're trying to find the fifth term, we're going to have 3 plus 4, and then 5 is n minus 1 4 times because we've added the common difference 4 times. All right. So then just simplifying, I'm going to do the distributive property here. And then I'm going to finish up by combining like terms. So then I've got my final explicit formula for any term. Okay, so recursively defined and explicitly defined. All right, let's do one more. Remember, when we're doing recursive, we have 2 parts. We're going to define the first term and then the rest of the terms. First term is 110. The a sub n is the term before that, a sub n minus 1, and then we have to find our common difference here, what's happening. So it looks like it's going down, so it's subtracting 7. Okay? Or another way to write this, if you wanted to alternately, would be a sub n minus 1 plus a negative 7. Okay? So that's going to help me over here when I'm ready to write my my explicit formula. I'm going to take the first term plus the common difference, which is negative 7 times n minus 1. I did the distributive property to simplify this part of the expression, and then I combine like terms to finish up. And maybe I want to check my work just to make sure that this explicit formula is working. So let's say we're trying to find a term that's already been found. So we are trying to find a sub 5, 1, 2, 3, 4, 5, the fifth term. So let's double check to make sure that our work is correct here. So a sub 5 would be negative 7 times 5 plus 117. That should work to get us the fifth term. Negative 7 times 5 is negative 35. And when I add that to 117, I get 89. So I have checked to make sure my explicit formula worked because it got me my fifth term of 89. I'm sorry. 1, 2, 3, 4, 5. Oh, yeah, 82. I'm sorry. 35. Let me double check here. I did that a little different than I did on my notes before I started. So let's do negative 35 plus 117. Yeah, that's 82, not 89. I'm sorry. In my notes, I had done the fourth term. So the fifth term will get me negative 82, or will get me 82, which tells me that I did it correctly. All right. Before class, I'd like you to write both a recursive and explicit formula for the arithmetic sequence listed out there.